Okay, 3.5 covers trig equations. They give us some objectives here. It says find all the solutions of a trig equation, solve equations with multiple angles, solve trig equations in quadratic form, use factoring to separate different functions in trig equations, use identities, use calculators. So we have a variety of options here for what we're going to be doing. So we're going to start here with our explanation. A trig equation is an equation that contains a trig expression with a variable such as sin x. The values that satisfy such an equation are called its solutions. There are trig equations that have no solutions. When an equation includes multiple angles, the period of the function plays an important role in ensuring that we do not leave out any solutions. So let's get started here with example 1. It says to solve 5 times the sine of x equals 3 times the sine of x plus the square root of 3. First thing we need to do is isolate the function on one side. So I'm going to subtract 3 sine x from both sides. That's going to give me 2 sine x equals the square root of 3. I'm going to divide by 2. Sine of x is equal to the square root of 3 over 2. Okay, so let's talk about that. Sine is the square root of 3 over 2. Now, I love my little chart that keeps, this tells me it's 60 degrees, or 60 degrees is pi over 3, where that's going to happen, and it's positive. And it's the sine, and sine is positive in quadrant 1 and quadrant 2. So, solutions to this are, if you are in this interval from 0 to 2 pi, then you will have that occur at pi over 3 and at 2 pi over 3. It's going to occur here and here. It won't happen down here because the y values would be negative, and it tells me that it's a positive. So sine is positive in the top two quadrants, quadrant 1 and quadrant 2. So the solutions for this are, because we could, if they tell us to go around the circle more than once, the solutions are pi over 3 plus whole number multiples of that. So it's pi over 3, which would be here. Or if I went all the way around 2 pi plus pi over 3, it would be 2 1/3 pi. It's every time you spin around, you could have another one. And this one is 2 pi over 3 plus 2n pi. So those are my solutions. Next example asks me to solve tangent of 2x is equal to the square root of 3, and they tell me that I'm between 0 and x and 2 pi, so I'm on the same interval that I was. Tangent of 2x is equal to the square root of 3, so solve this equation. Tangent of pi over 3 is equal to the square root of 3. I get that from my chart right there. It's pi over 3. So we know that 2x must equal pi over 3. And then all the rotations that could happen, so plus n times pi. The reason it's n times pi is because now we're dealing with the tangent. And the tangent is positive when x and y have the same sign. So that's positive in quadrant 1 and quadrant 3. So you only have to go around. It's not a whole loop, it's a half a loop. So it's a pi, a rotation of pi. But we want to know what x is. So we're going to divide everything by 2. So x is equal to pi over 6 plus n times pi over 2. When n is 0, we're going to have x is equal to pi over 6 plus 0 times pi over 2, which is pi over 6. When n is 1, we're going to have x is equal to pi over 6 plus 1 pi over 2. which would give me pi over 6 plus 3 pi over 6, which would give me 4 pi over 6, which is 2 pi over 3. When n is 2, x is equal to pi over 6 plus 2 times pi over 2, which is pi over 6 plus 6 pi over 6, which is 7 pi over 6. When n is 3, we have x is equal to pi over 6 plus 3 pi over 2, which is pi over 6 plus 9 pi over 6, which is 10 pi over 6 reduced to 5 pi over 3. So the interval from 0 to 2 pi, we have pi over 6, 2 pi over 3, 7 pi over 6, and 5 pi over 3. Those are my solutions. Our next example asks us to solve for cosine squared x minus 3 is equal to 0 on the interval from 0 to 2 pi. So we start here, we're going to add 3 to both sides. So this says 4 cosine squared x equals 3. Divide by 4. Cosine squared x is 3/4. I'm going to take the square root. Which is cosine squared becomes cosine, and then I have plus or minus the square root of 3 over 2. Okay. Well, when the cosine is the square root of 3 over 2, then I'm at pi over 6, and it says plus or minus, so I can have all the time, every single time I have a reference angle of pi over 6, it's going to work. So it's going to happen at pi over 6, which is 30 degrees. When I am over here, I am 1 pi over 6 away from pi, so that puts me at 5 pi over 6. When I'm here, I'm 1 pi over 6 past, which gives me 7 pi over 6. When I'm here, I'm 1 pi over 6 short of 2 pi, which is 11 pi over 6.